Welcome to day 3 of our challenge, where we're looking at the differences between binary logistic and conditional logistic regression. They sound similar in that both have the word logistic, but they're very different in terms of the data structure that is assumed. When we talk about the data structure, I think we can look at it this way. When we use a standard logistic regression, you can see that we are assuming that the data are independent and identically distributed, which is just a fancy way of saying that each row in our data set is unique and has the same distribution of means. So as you can see in this screenshot here, each row has a unique color. This looks like a rainbow. All the colors are represented because each row has a distinct color of its own. Here, however, we see that we still have the same number of individuals, 14. But in this case, you can see that some rows have the same cluster. So for example, rows number 1 and 2 are both yellow. Here the next 3 rows are both brown, and so on and so forth. So despite having the same number of individuals, you have less variation in colors. Hence, we have less variance when we have clustered observations because individuals are clustered together. And that's a problem for us because less variation, for example, here in colors, means that we will have confidence intervals that are very narrow. And narrow confidence intervals means that there's less likelihood of overlap. And less likelihood of overlap means that we are more likely to declare a result as being significant even when it is not. So that's a problem, and that's why we need to use the appropriate methods for the appropriate data. When we have clustered observations like this, like when we have in a case control study, a matched case control study, we need to use conditional logistic regression. However, when we have data sets that have the IID assumption, then we can use the standard logistic regression. Now, for our case study today, we're going to be analyzing a data set that came from a case control study. We will do the same analysis with a conditional logistic regression, and we'll repeat it with a standard logistic regression to see the differences. And it is helpful for us to dive a little into the epidemiology to understand the statistics. So next few minutes, I'm going to talk a little about what a case control study is so that when you address the challenge, you'll understand it better. So a case control study, also called a TROHawk study, is a poor man's version of a cohort study. The word TROHawk is simply reading cohort backwards. When you read cohort backwards, you see it's TROHawk, and that's why it's called a TROHawk study, because it's a cohort study that is done backwards. Now, when we do cohort studies, we think of the Roman cohorts. These were soldiers. They would leave Rome together, all healthy and alive, and as they went together, they all traveled together and died together. And that's the idea of a cohort study. A bunch of people start off healthy, and then we'll follow them over time to see who develops the outcome of interest. So in the cohort study, we start with the healthy, and we try to track people to see who becomes ill or dead, whatever the outcome is. It becomes immediately apparent that it takes a lot of time and a lot of money to follow people over time. And time and money is something we don't have often in the real world. And that's the idea behind a case control study. So instead of waiting forever for people to develop an outcome, in a case control study, we start off with individuals who are already sick. And then we try to figure out, okay, what made them sick? So the idea here is that instead of following a lot of people over time to see who falls sick, we start off with what we have in hand, which is individuals who are already sick. And we try to determine the exposures that made them sick. So our case study today is from an actual investigation, of food poisoning in the US, where we have individuals who ate different foods and from a restaurant and got sick. So your challenge today is to try and figure out what foods made them sick. You have to bear in mind the design of a study. Remember that in a case control study, we have cases and we have controls. And we typically match the controls to cases so that we reduce confounding. So if we identify for example, a young white case, we will find a young white control so that we're comparing apples to apples. But the problem is that when we match, we end up with this issue here. Matching creates a problem where we now have rows that are not independent. Because if I matched a control to a case, it means that they are of the same set, they belong in the same set. And so that introduced clustering, and that is why we have to use a special analysis technique when we're analyzing case control studies. So let's have a quick look at our data set to see what we are going to be analyzing. This is the data set. This came from an actual case control investigation. And so you have this is the ID that tells us the matched sets. So this is in this column here, you have CACO, case or control status. 1 means that you are a case, 0 means you are a control. So you can see that these two individuals here, they are part of a matched set. You can see that this ID is the same for both of them. And that is what a case control does. It is analyzing the data sets within the matched sets. If we fail to account for that, we'll have results that are not valid because the confidence intervals will not be estimated correctly and will be wrong. So let's go over to the chi-squares platform and let's see how we do actually analyze data from a case control study. And we're going to compare that with a standard logistic regression to see the differences. So we're going to go to estimate and we'll come to regression analysis as usual. We will select the conditional logistic regression analysis and we'll select our outcome variable. In a case control study, the outcome are the exposures in the real world. Remember the foods that people ate, whether it was peanut butter or apple or whatever it was, those are our outcomes. So you will have to select the outcomes one by one. So for this particular run, let's say I'm interested in seeing whether peanut butter was associated with the outbreak. So I will select peanut butter here. And the next question says, choose the variable that is the group identifier for each matched set. So here I'm going to select UID2. That is the variable that indicates that this control and this case are part of a matched set. Next, I'm told to select the variable for case control status. This will be the variable CACO, case control. So I'll select that. And then next it says, please choose which unique value represents the cases. The cases are the ones. So I'm going to select 1. Please do not select 0 when you intend. You should absolutely select the cases here because in the case control study, we're comparing cases compared to the controls. Next, we are asked to choose any additional control variables and their reference groups. If we had additional control variables like age or gender, we would select them here. Now, it's very important to note that in a case control study, if we matched on a particular variable, we cannot control for that variable again in the analysis. That's like double jeopardy. The whole point of matching is to control for confounders. So we cannot control for the same confounders twice. So if I matched on age and sex and race, it means I cannot select those variables here, even if they exist in the data set. So you see there's sex here, but I won't be selecting sex because I already matched for sex in the design of the study. So it is not uncommon when you're analyzing case control studies that you only have the case control status variable as the only predictor. So you don't have to select here if there are none. So now, once we have all of those, we can then click on estimate, and the platform then takes that information and it will run a conditional logistic regression analysis in the background. And so now we have our results here. We have the variable, which is the case control status. The comparison is between the cases, which is the ones, versus the controls, which are the 0. We have the odds ratios with 95% confidence intervals here. So here we have 0.39, confidence intervals 0.16 to 0.93. This tells us that compared to controls, cases had 0.39 times lower odds of reporting eating this food item. And that was a statistically significant difference. So what does that mean in terms of the outbreak? It means that this this food item was not associated with the likelihood of the outbreak or of symptoms among the cases, since they had a lower likelihood of reporting eating the food. So those are the kinds of decisions we make in the field, and that's how we come to decisions as to whether this food was implicated in the outbreak or not. Notice that the conditional logistic regression has no intercept, and I have already provided an explanation for why that is so in an earlier post, which I'm going to include a link to so that you can read for more information. Now let's repeat the same analysis. You can look at the plot and you can look at the text which the platform writes out for us and the metadata. Now let's repeat the same analysis now in a standard logistic regression. Now what would you expect to see? You will expect to see that the odds ratios and the confidence intervals in particular, you will expect to see that they will be much narrower when you perform a standard logistic regression than what we have now, because the standard logistic regression would not have accounted for the matched sets. So let's go over now and let's click on rerun. But this time around, we will not select the conditional logistic regression. We will use a standard logistic regression, which is in this case a binary logistic regression. Binary because it accepts outcomes that are dichotomous, 0 or 1. Our outcome here will still select peanuts, and the predictor variable here is the case control status. Note that in a standard logistic regression, there is no allowance for us to select which variables are a matched set. The reference group here, we're comparing the results to the control group, so we'll select the reference group as the zeros, and now we can estimate. So now it's performing a logistic regression analysis, but not accounting for the match set. So here we see we have the odds ratios are slightly different. The results are also significant, but notice that the p-value is much smaller and the confidence intervals are much narrower than what we would expect when we had a conditional logistic regression. Notice also that in a standard logistic regression, you obviously have an intercept. So these are some of the key differences when we analyze data with a conditional logistic regression versus a standard one. But the moral of the story is that if your data sets include match sets or matching during the design, the only way your results will be valid will be by using an analysis type that accounts for the matching. In this case, by using a conditional logistic regression. So the challenge for today, the task for today, would require that you analyze that same data set. Like I said, that came from an actual investigation. The beauty of it is that you get to see how messy data sets come from the field, especially during outbreaks, and how messy they are and how relatively small they are in terms of the sample sizes. And yet, despite all of those challenges, how we make the best of it and make inferences that save lives. So looking forward to getting your responses submitted. Thank you.